So my name is Ronan Cremin. I'm from Afilias Technologies, and I'm here today to talk to you about delivering performance on a diverse web, because we see this as a big problem that people like you are experiencing. This is what I'm going to talk about today. It's a problem and a solution. The problem is a new web reality, and that new reality stems from device evolution, a more diverse and a more global web, and that has led to something of a performance crisis. So I'm going to tell you how you can address this problem with NGINX today. Just by way of introduction, I'm going to be talking about a product called Device Atlas. It's a product that we produce. It's a traffic intelligence product, and I'm from Afilias Technologies. We like to think that we play quite a big role in this industry. We are WC3 contributors and editors. We've helped author standards. We do a lot of advocacy and outreach on mobileforge.com and internet.com. We're partners with NGINX, we're partners with Varnish, the GSMA, and Digital Envoy. So we like to think that we play a role in this industry. So that's who we are. Now let's talk about the problem. So to set the scene here a little bit, I want to talk about a new web reality. And this is a new reality that was driven by two things: the evolution of mobile devices and the changes that these have forced upon the web. So let's have a look at what has happened. So the changes that the web has had to undergo in the last few years have been driven by device evolution. So let's have a look at how that actually played out. The web is 25 years old today, or not today, but this year, I think. But if you look at the history of it, for much of the first almost 20 years, not a whole lot happened in terms of devices. The way that you utilized the web was on a PC. And while the PC got faster and it got better connected and had more RAM and so on, its fundamental characteristics didn't really change. It was a thing that sat on a desk that you went to get on the web. So for the first 20 odd years of the web's history, that didn't change. And I call that the dark ages of the web. Then in 2007, something happened. We suddenly had netbooks, we had iPhones, and from there we have multiple different smartphones, tablets, TVs, Google Glass. And now today, diversity is the new normal. This is how people get on the web today. So in the blink of an ecological eye, diversity has become the new normal. We've had a Cambrian explosion of devices that are now on the web, reaching your site. Corresponding to this tipping point in devices, we've seen a huge penetration of mobile devices worldwide. So just last year, the number of mobile devices in use out there surpassed desktop devices in 2014. That was the tip-over point. And following this tip-over point of devices, the traffic pattern has followed suit, as you might expect. This is Facebook's monthly active users by different platform types. You can see the thin gray line is the number of mobile-only users. And just in June this year, that surpassed both desktop users and desktop and mobile users. So mobile traffic is now the majority for many sites. And in fact, this happened many years ago for some sites, for news sites, for sports sites. This changeover point happened years ago. So mobile traffic is now the majority for many people. We tend to think that here in the US and in Europe and so on, that we're kind of leading the charge here, that we all have our fancy mobile phones. But in fact, we're behind. If you look at developed Asia Pacific, the Caribbean and Latin America, the US and Europe trail these countries in terms of mobile penetration. So we're actually behind. So what we see here is actually a lagging indicator of what's happening elsewhere. Mobile is the new normal. So we lag the developing nations in terms of penetration. So this is all leading up to this situation here, where we are now dealing with a truly worldwide web. The web up until now has been something of a Western world web. It is now truly a worldwide web. So our growth is beginning to peter out in North America. We see China and India just beginning to ramp up. So the growth is coming from places outside of here. So ultimately what we have now is a worldwide web, which is what it was always supposed to be. In other words, a truly global worldwide web and a diverse web with multiple different devices. Interestingly, some of the fastest growing markets don't use apps at all, basically. So if you look at, say, Asia Pacific, web usage is dominant there versus in the States, where it's kind of the other way around. So many of these fast-growing markets don't use apps at all. They use the web in preference. So that's where we are now with mobile traffic and device penetration. Let's have a look at how the web has evolved to match this challenge. So Back in about 2002, the first devices that could actually get on the web were like these ones you see in the slide. They were pretty limited devices, and there was this huge gap between portable and capable. A device was either portable or capable. There was nothing in between. Fast forward to today, and every ecological niche is filled. We have every shape and size of device you could think of at different price points, different CPU levels, different screen sizes. Every ecological niche is covered. And this isn't just about screen sizes and shapes and sizes, it's about context and interface and input methods. So if you think about it, on a desktop, you have a screen that's quite big, you have a resolution that varies from medium to high, you've got a keyboard and a mouse and the viewing distance of about 70 centimeters, and you're typically in a sitting context when you use this device. On a mobile device, by comparison, you've got a physically small screen with a resolution that varies from small to quite large, but with a touch interface, and you use it in completely different contexts. You could use your mobile device and you're sitting on a couch, standing at a bus stop, actually walking along or sitting at a desk. So the breadth of contexts that you use this device in is huge compared to the desktop. Tablet, something similar. The interface is mostly a touch interface, the viewing distance is different, the context that you're sitting in is likely to be different. You're likely to be on a couch or sitting at a desk. Then if you look at TVs are fully valid web devices these days. They've physically huge screens. The resolution varies from big to very big indeed. You may have a wireless keyboard or a TV remote as your input method, but the context is limited to just sitting on a couch typically. So if you look at it, all of this breadth of context, interfaces and input methods, no other mass medium has had to deal with such change in such a small amount of time. If you think about books, radio, I'm trying to think of the other example, books and radio, TV, these mass media did not have to handle such change in their lifetime. They stayed almost the same for their entire lifetimes. The web, by comparison, has had to handle this sea change in the nature of the devices that use it and the nature of the context that people are in when they do it. So this has led to responsive web design. You've probably all heard about this. Responsive web design is the default response of the industry to this challenge. And it almost by definition, responsive design is a one-size-fits-all approach. It sends the same package of content to everybody and lets the device work out what to do. So it is a useful technique. It's not bad. It has its issues. Notably, it doesn't attempt to make wholesale changes to the page. It's a layout technique. It moves things around. It changes image sizes. It doesn't make wholesale changes to the page to address the different contexts. So it's primarily a layout technique. So useful, but not without its issues. In the meantime, while all of this is happening, the web ecosystem has been evolving as well. We've seen, particularly recently, the web advertising ecosystem as a way to monetize free content is beginning to stutter and probably fail. And as a result, sites are adding more ads, and we're left with this situation here where we're just piling more and more stuff onto our web pages. We're using more third-party JavaScript libraries than ever in delivery of our sites. Web fonts are now routine, everybody's using them. And rich web frameworks are being used to abstract some of this complexity away. So all of this has led to this. This is the average web page size as measured by the httparchive.org, measured in June this year. And you can see that the headline number here, I guess, is the average web page size is now almost 2.2 megabytes, which if you think about it is pretty outrageous. It's enormous. Most of this is images, but it's also fonts, videos, scripts, and so on. So this is the state of the union, if you like, today. And if you think about it, you could argue the case that delivering that chunk of content to a desktop device over a DSL or a cable connection, it makes some amount of sense. It's not the worst thing in the world. It could be better, but it kind of works, okay? But to deliver the same thing to an iPhone that's connected over a 4G connection, which can't even view the images at their native resolution, is looking pretty inefficient. And remember that even a high-end smartphone, if it's badly connected, is in effect a feature phone. So an iPhone 6 Plus on conference Wi-Fi, it's a feature phone, right? But to deliver that same chunk of content to a $100 Android phone connected over a 2G connection is bordering on insanity, because that device will simply discard almost all of the data that it gets. It just can't avail of that chunk of data. It can't do anything with it. It can't render the images at the native resolution. It won't use the web fonts, and so on. And to add insult to injury, that person may be paying for that data, so the data that you've paid to download may be of no use to you. So we're stuffing giant slugs of data down thin, unreliable pipes to devices on the assumption that they're going to be able to use it, and maybe they can't. If you step back and think about it, it makes no sense to send the same chunk of data to a low-end Android phone over a thin connection, the same content that we send to a MacBook Pro on a fiber connection. It just makes no sense at all. But that's what we're doing. And a noted web developer, Scott Giel, has summarized this quite nicely. He says that delivering a website that only works for the luckiest, most fortunate users on the web is uninteresting, not to mention bad for business. So this is where we are today. We're in something of a performance crisis. This is a sheep that managed to escape shearing for 6 years, and he's gotten kind of big. So it's not just me saying this. These are some of the headlines we've seen over the last couple of months. Vox Media, which is the publisher behind The Verge and a bunch of other sites, has gone as far as to declare a performance bankruptcy. They said, we're done. We don't know what to do. We can't deliver content that's light enough to make sense. I myself tweeted this out a couple of months ago. I pointed out that in about 7 months, the average web page size will be the same size as the Doom install image. And think about that. I mean, that just makes no sense at all. With all those levels, all those characters, the music, everything, that's our average web page size in a few months' time. And to give you a sense of like the resonance this has with the community, look at the retweet count. It's increased since then, but it's up to about 4,000 retweets now. People genuinely think that we have a problem here. And incredibly, all of this is happening at a time when all the data say that performance is critical. You've got to get performance right. If your business is on the web, you have to fix performance. I'll give you some data points here. Walmart have said publicly that a 1 second speed up in their page load time resulted in a 2% increase in conversions. Shopzilla have said that a 5 second speed up in their load time resulted in 25% extra page views and 7 to 12% increase in revenue. So this bottom line numbers here. Mozilla found that when they lightened up their site, the load time went down by 2.2 seconds, and they got 60 million more downloads over the year. Amazon has said that every 100 milliseconds of speed increase results in a 1% increase in bottom line revenue. And think about that, 100 milliseconds has a direct measurable effect on bottom line revenue. Yahoo have said that a 400 millisecond speed up results in 9% extra page views. And last but by no means least, Google have said that temporary performance problems cause long-term damage to your traffic. So you guys may have heard about this, but Google periodically introduces random delays into the load time of its users randomly and checks the result. They have found two things. Number one, 1/10 of a second is enough to produce a measurable decrease in performance for any given user. And number two, and perhaps most importantly, people remember it. So for months afterwards, the affected users have decreased traffic. So it seems like subliminally people remember this, and it reduces your likelihood to click on links. So temporary performance problems cause long-term damage. And this is coming from the masters of the craft, Google, so it's true. So all of this is happening at a time when performance is becoming more important than ever because the constraints are actually growing. As the web becomes more global, you're dealing with users who are connected in different ways on different devices, different connectivity levels. So this is happening at a time when you need to be more careful than ever. And there's something of a fallacy out there that smartphones have now caught up. We have Chrome, we've got Safari on our mobile phone devices that can handle anything. And they kind of can, but really, if you think about it, a device that fits in your pocket is never going to be as capable as one that fits in your desk. CPU, battery, RAM, the whole lot. It's just never going to be as good. Additionally, with all these mobile users now on the web, the mobile context tends to be much more sensitive about performance. People have a much lower ability to accept delays when you're in a mobile context. You're rushing around, you're looking for something, a delay is critical. So given all of this, how do you actually deliver performance on a diverse web? This is what we're here today to talk about. And I think the best way to address this is to look at how the masters do it. So this is the Alexa top 10 sites. These are the busiest sites out there. And they're going to look at a few of them to see what lessons can be learned from how they do it. These are the leading brands. These are the guys who have to get it right. If these guys fail, their business fails. So I've run an analysis on a few sites using our tool MobileReady, which is mobileready.com. And unlike most tools out there. This one splits the single view of a site into the diverse views that actually represent the traffic that you're getting. So instead of just saying this is a page, we show you how that page loads on different devices, because we think that's critical. So here you see google.com as loaded on a desktop, a high-end phone, a mid-tier phone, and a low-end phone. And people tend to think that google.com is the same site across the board, but nothing could be further from the truth. If you look at it, look at the numbers here. The page size is different. The number of resources on the page is different. The resources themselves are different. I mean, literally every single thing about this page is different on every single device. Even the ratio of HTML to JavaScript images changes completely across each device. If you look at the rightmost one, the low-tier phone, note there's no JavaScript. They're sending a 3 kilobyte page all in, including images, versus a 300K page on the desktop. So every single version of the google.com is different for every single device because it works. They need to. Let's have a look at Amazon. So again, Amazon, superficially, it looks similar. There's broadly speaking the same messaging is there, but look at the page composition, look at the number of requests, look at the page size, the ratio of images to JavaScript to HTML. It's completely different on every single device. Note that the lightest experience is 25K, the heaviest one is 2-point-something megabytes, different across the board. This is how they do it. So enough with the American sites, let's have a look at another one. This is Baidu.com. Baidu is, I think, the 6th busiest site on the net. It's the most popular web search engine in China. But look, they're doing exactly the same thing. Superficially, the site looks the same. Under the covers, they're delivering a different package of content to every single device. It's crafted per device. So if you were to extend this analysis out to the rest of the Alexa top 10, this is what you find. There are some common approaches that all of them do. First of all, they're light and efficient sites. Most of these sites are way below the industry average. That is the single best thing the best way to start. Secondly, they're all doing server-side adaptation. They are all serving different content for different devices. And if you look at the table on the right, they're serving different HTML, different JavaScript, and different images for every single device. The sole exception to this is the Wikipedia, which doesn't actually have device-sensitive JavaScript and images, but their use case is a little bit simpler. But they're all doing this. Thirdly, they're prioritizing content differently for every device. So they're raising some chunks of content, lowering other stuff, hiding stuff, adding stuff. They're prioritizing the content per device type. One other characteristic I want to mention is what we call their dynamic range. So dynamic range deserves a bit of explanation, and it's our term for measuring how agile a site is in the face of diverse clients and connection speeds and so on. So taking google.com as an example, the lightest representation of Google that you would see on a feature phone is fully 122 times lighter than the desktop version. And that's pretty remarkable. The desktop version is light enough as is, it's 360K, that's pretty light, but the mobile version is 3.1 kilobytes all in, including images. And that's pretty remarkable if you think about it. Another example of how Google are so obsessed about this, their new logo is 305 bytes. Not compressed, 305 bytes. They're relentless about this. So if you look at the dynamic range of the various tranches of the Alexa 100, it's a very strong proxy for a high-performing site. Sites 1 through 10 have a dynamic range of about 40, sites 10 through 20 have a dynamic range of about 20, and it peters out pretty rapidly after that. So it's a very strong indicator of a high-performing web brand, is how agile they are in the face of differing client requirements. So that's dynamic range. Another thing that they're all doing is what we call adaptive content. So people think that google.com, if you search for a given thing, the results are the same on mobile and desktop, and again, could not be further from the truth. This screenshot shows you a search for taxi on a desktop device and a phone. And at first glance, they're very similar, but actually there are a ton of different things going on here. First of all, on the mobile device, Google has prioritized the local content up because they think this person is in a particular place, they're looking for stuff that's in that place. So let's raise the priority of that. Secondly, the actual way that the results are presented is different. So on the mobile device, they have a click-to-call number for the companies. On the desktop side, they're showing the actual street address of the companies. Another point, they've decided that on a desktop device, the image search use case is quite likely to be something that you're looking for. So they have the pictures of the taxis quite high. On the mobile device, it's ranked way down because you're probably not going to do it. You may do it, but it's not as likely. So they're moving stuff around the whole time. And all of the Alexa top 10 are doing this to some extent. So they're doing this with server-side adaptation, and the reason they're doing this is because it lets you optimize on the first load. From the very first visit, you can get everything right. You don't need to do client-side interrogation, move things around. You can immediately serve the correct images. You can tailor the content for the type of the device. Not necessarily the screen resolution, but the type. Is it a tablet, is it a desktop, is it a bot? So you can tailor the content per device type. And I mean, in summary, I guess, the more you can do on the server, the less your client has to do, which increases the speed and the user experience. People will typically ask at this point, can't you do this all with responsive web design? To a certain extent you can. You can do swap out images depending on the screen resolution, but this is the fully correct way to specify an image using the new source set attribute that arrived recently. If you can deal with that, or your authors can deal with it, or your CMS can deal with it, great. But again, it only works on devices for which this attribute is supported, and that is absolutely not all devices. And secondly, you can't actually wholesale change the page content. You can change the images, but that's kind of it. You can lay out things a little bit differently, but you can't actually change the HTML content that is delivered to the site with responsive web design. So it sort of gets you some of the way, but not fully. So the limits to this, the benefits of the server-side adaptation are not limited to the site owner, or to the visitor. The site owner also gets quite a lot. Your hosting can get faster and cheaper. I'll talk about that in a minute. You can lower your bandwidth and CDN bills because you're delivering less to each client. You can get more out of every server. You can literally serve more traffic from each server. And critically, all of this enables you to get better market reach. Let's not forget that us here in this room are the edge case. Most people do not have iPhone 6's connection, 4G connections. Facebook has said, just I think last month, they have more 2G users than 4G users. We are the edge case. A guy called Chris Zacharias from YouTube summarized this quite nicely. A few years ago, he took it upon himself to take the YouTube page, the container page for the videos, and make it lighter. He stripped stuff out that wasn't needed and lightened it up. For the next couple of months, he sat back and watched what he hoped would be increased load times for his users, and found, to his astonishment, that the load times had actually increased on average. So on looking into it further, he found out that the reason for this was entire new countries had come online as a result of lightening his page. Literally new territories were now using YouTube that did not use it before. So he says it quite nicely, by keeping your client-side code small and lightweight, you can literally open up your product to new markets. That's worth remembering. Market reach is facilitated by making your site light and adaptable. I mentioned bandwidth savings. So for all of you guys, this will vary, but if you make the assumption that mobile and desktop are 40% of your traffic each, and bots are 20%, and you start with a page size of 1 megabyte, which is actually kind of small, typically I would expect that with some adaptation, that page size can be dropped by about a factor of 3 on a mobile device, and for bots also. And if you multiply that out by the traffic spread, it's really easy to get a 40% reduction in bandwidth. And depending on your site type, it could be way more, but typically it's easy to get it in this ballpark. This just gives you a feel for what can be done. Some other benefits of site owner: if you do this traffic detection at the server layer, you can adapt sites wholesale within the infrastructure. You don't need to get the developers to do it. You can do everything for them. You can protect visitors against bad sites. If marketing drop a huge site on you with giant images, you can protect your users from that by resizing things appropriately within the server. You also get additional levers for controlling site delivery. You can send different content to bots. You can add stuff, remove stuff, and basically tailor the site as suits you for optimal delivery. And we do this ourselves. One particular case study, we use NGINX plus Device Atlas, our product, to serve 200,000 small business sites around the world. These are owned by small businesses in 140 different countries. And we have found that without server-side adaptation, we need about 40 servers to deliver that load at a cost of $10,000 a month, or $1,400 in bandwidth. With server-side adaptation, we can lighten up the site, and 20 servers is enough to deliver the same load, while also delivering a much better user experience. We have sub-second load time for most users on most devices. So significant savings are possible. So how does one actually do this with NGINX? How do you guys actually achieve this end? I've been talking about Device Atlas. It's the class-leading traffic intelligence product, and it works with NGINX. And here's how you do it. So you go get it, you download it, you untar it, and make it. And that builds our detection code into the NGINX binary. You then need to add a config line to NGINX to tell it where the data is, and that's it, 2 steps. Then it's up to you how to actually utilize this traffic intelligence. The way it manifests itself is in every HTTP request, you now get additional details. You get the device type, you get a whole wealth of details that are available to you either in nginx.conf or the new JavaScript engine that's coming, same thing, or you can pass them downstream to the users behind you in the form of environment variables or HTTP headers. So everybody downstream of you gets to use these properties, if they choose to, in a very language neutral way. So what are the properties? What do you get from this? You get the device type. Is it a bot? Is it a tablet? Is it a phone? Is it a set-top box or an e-reader, Xbox? You get to know the hardware properties. What's the physical size of the screen? What's the pixel size of the screen? What carrier it's on if you've chosen to use this module. Is it on Sprint or Verizon? What's the name of the device? Is it a Galaxy? What's the manufacturer? What's the marketing name? You get the browser properties. Is it Chrome or WebKit? What's the rendering engine? OS details, whether it's Android or iOS or BlackBerry and so on. Some JavaScript properties, network protocols. Is it a 3G phone, 4G phone, 2G? And finally, some HTML5 properties. So overall, there's 160 properties in each request, but it runs so quickly that we do this lookup on every single request because it's quick and light. So why would you do this in NGINX? Why not let the app developers behind the scenes do this themselves? 2 reasons. Number one, it's cheaper. It's more efficient to do this in NGINX with compiled C code than it is behind the scenes in PHP or Java or Ruby or whatever. It's also easier because you get one point where you do it, and the resulting intelligence is available to everybody downstream of you. So be it Node.js, Ruby, or PHP, everybody gets to inherit the properties that you pick up for them, and it's available downstream. So we looked at how the Alexa top 10 are doing some of their magic. Let's look at how we can actually use this intelligence to do the same thing. So I'm going to show you an actual worked example. So the first thing to look at is image optimization. This is the single best way to make your site agile in the face of devices and connection speeds. Images are typically 70% of the page weight, so they're clearly the first best step for optimizing your site. So in order to make it a reproducible result that anybody here can try, I took an off-the-shelf responsive web design template. This is available at that URL there. It's a nice template. And the over-the-air size of this template, as delivered over HTTP gzip connection, is just under a megabyte, 998 kilobytes. So actually quite a light page, to be honest. But I'm going to show you how you can make this page much faster and much lighter in about 5 minutes. So first of all, you need to add some stuff to your NGINX config file. You need to compile in the imagery sizing module. This is one of the standard supported modules. And the config, I'm not sure if you can read that, but the config on the right, all it's doing is it's saying, if we know the device screen size, let's resize the images to that size, because to do any more is a waste of bandwidth. The device cannot show any more resolution than that, so let's resize them down. Once we've done that, we cache the image so that we don't have to do it again. If another device comes along with the same screen size, we're good. We can just serve up the same thing again. So that's all that that's doing. It looks complicated, but really it's not. So if you just do that, and this takes about 5 minutes, here's the result. So for the desktop device, the before size was 998 kilobytes. The after size, same thing. We haven't tried to do anything with that at all. But for the iPhone, the resulting site is now 1/3 of the size. For an iPad, the new result is about 2/3 of the size. And for a low-end phone, it's about 1/4. So this site has gone from having a dynamic range of 1 to about 4 with about 5 minutes work. And this has huge benefits. And critically, the site owner has no reduction in functionality. They can't even tell that this has happened. It just got better. And also, your content people, the people who sit behind you guys at the NGINX at the front there, have had to do no work at all to make this work. It just works. So what are the benefits? What does the user see? So if you take a 1 megabit connection bandwidth with a 40 millisecond round trip time, on an iPhone that site has gone from a 5.4 second load time to a 1.9 second. So from okay to class leading, just straight away. That has a huge result on the conversion rate. It will, according to, quote, a large internet retailer, That will change the conversion rate from about 0.7% to 1.4%, a 2x improvement. Bounce rate will change from about 35% to 26%, a significant improvement. What about your server? What does this mean to your actual server performance? So to test this, I ran a JMeter test simulating 200 users on a real-life mix of traffic. So some desktop traffic, some mobile traffic, some bots, et cetera, et cetera. I ran 200 threads, loading as fast as possible, no caching, et cetera, and this is what happened. So with the stock NGINX, the black line is the request per second. So that topped out pretty quickly at about 15 requests per second. That sounds low, but remember that this content has been delivered over a deliberately restricted line simulating real-life conditions. So that the server topped out at 15 requests per second. The users at that time were seeing about a 20-second load time, which is poorish. I mean, it's pretty poor. 20 seconds is slow. If you do what I just described, if you add device intelligence and just turn it on and do the imagery sizing, this is what happens. The server capacity about doubles up to about 37 requests or 35 requests per second. And the user load time quarters. It goes from 20 seconds to 5 seconds. So you get huge gains to both your server and the client's responsivity with almost no work. Your server capacity is doubled, your user load time is quartered. That's a big gain for a few minutes work. So just with image adaptation, it's really quick to implement. It results in a better user experience, lower bounce rate, higher conversion, higher per server load, and reduced bandwidth costs. So that's one thing that the Alexa Top 10 are doing. The other thing is content tailoring. Now, so content tailoring is typically used to add stuff, remove stuff, change the UX, change the priority of stuff on the server side, depending on the device type. So not simple things like screen resolution, the type. So as an example of this, Netflix, who's a customer of ours, they encode their videos 120 different ways based on expected viewing distance, CPU power of the device in question, the resolution of the device in question, and they need a way to pick which version of the video to serve up. So content tailoring is what they do to address this need. So I haven't chosen to show an actual worked example because the way that you would utilize this tends to depend on the particular use case, but I'm just showing how easily those properties are now available regardless of device type, regardless of your language or environment. Everybody downstream gets to benefit from these properties in a really easy way. In this case, I'm just showing how a check for whether or not it's a tablet would work in Java, PHP, Ruby, and Node.js. And obviously that will work in any other language as well. But so with a couple of lines of logic and the free context detection or device detection that happens up front, the downstream guys get to utilize this in any way they choose. So you may be asking, what's the server overhead for this? What's the cost? Yes, there is a slight overhead for the lookup. We have to do it on every request. But on a server that NGINX will do tens of thousands of requests per second, we will typically do millions or hundreds of thousands. So it's a really, really small cost per connection. Yes, some memory is consumed. We consume typically an extra 12 to 100 megabytes, depending on what property set you wish to avail of. So it's controllable by you. And yes, you do need to get updates for the data every so often, but that's up to you when you decide to do it. It's a pull rather than a push model. It's just a curl request. So just to recap of what we talked about, in our opinion, embedded traffic intelligence is basically table stakes at this point. Yes, you can hope that sending the same content to everybody will work, but you know what? You're competing against people who are doing better. Everybody else is doing per device content. It's hard, but the web has moved on. Because it's a more diverse web, you need to try harder to serve everybody. By doing this, you can reduce your server load and your bandwidth costs while also improving the user side experience. It's not difficult to do. The time to value is really, really quick. Everybody downstream of the NGINX layer gets to benefit. And this is a tried and trusted technology. This isn't a new thing. It's used by all of these people. It runs the gamut. It's top internet brands, large retailers, traditional brands like IBM and Walmart, banks, operators, publishers, analytics. This is used by a lot of people, and it's effective and proven. It's a trusted technology. And finally, one more thing. There's a free Device Atlas license in your bag, hopefully. It's a perpetual license. It doesn't expire. You can renew it. And you can download and try it and do everything that I just talked about. So that is it. Thank you very much. I think we've got about 5 minutes for questions if anybody would like to ask. Yeah. Okay, so the question was, there's the server-side cost to doing this, but he's asking, is there a latency exposed to the client? We do millions of these per second. It takes like less than a millisecond to do this. So no. It's a local database, yes. It's a local database, and there's a cloud version as well, but most people in this kind of environment will choose the locally deployed version. There's no latency, really. I think there's a question, I think this guy's next. Sorry. Okay. So the gentleman was asking, is web traffic actually decreasing for mobile traffic? In our experience, it possibly is in some places like the US and Europe. Absolutely, definitely not overall and globally. And I think what you're going to see is things like HTML5 applications beginning to take over from native apps, because HTML5 apps now support web push, they support geofencing, they support a lot of the things that previously could only have been done in native apps. So I think we're on the cusp of a change there, but there is a slight tendency for what you said. I mean, I think in North America, what you said is true, but globally, no. Okay. Okay, I'm not sure if I can comment on that, but yeah, from our point of view, the web traffic is overall is still increasing. I think you were next, right? Okay. Correct. Yes. Yeah. So the guy's asking, are the images, the resulting resize images cached? Absolutely yes. So there's a once-off hit per image size, but that immediately goes away, and it's free sailing from there. Any other questions?
I think that you kind of even underestimate the impact on performance on mobile, because I'll go away from it.
Yeah. Yeah. Yes. Yeah. Right. We keep thinking about this. Every year we reevaluate the decision. We haven't done it because once you pick a categorization rubric, it goes out of date. I mean, for example, that is possibly the solution to the problem, because we work with Netflix, and Netflix care about video performance, but Etsy and other customer of ours doesn't care about video performance. So the way that each person categorizes the devices depend. And a decision even about what a smartphone is depends. I mean, the original iPhone 1 is technically a smartphone, but today, not really, right? Just about. So that would be the ideal way to do it, but we haven't done that just yet. Our job is to give you the information, and then you decide what to do with it. Anything else? Okay, thank you everybody. Thank you for your time.